LeetCode question contains duplicates. So today we're going to solve a LeetCode question called contains duplicate. The question is, given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So let's take a look at example. The first one is 1, 2, 3, 1. In this case, the first element is 1, the last element is also 1, so the output is true. The second example is that 1, 2, 3, 4. In this case, we have all the elements to be distinct from each other, means that they're all different. So the answer is false. And then another example, we have 1, 1, 1, 3, 3. So without even looking at the rest, we know that this is true because those are duplicates. We have 3 ones. So how shall we solve this problem? There's two methods that I'm going to introduce. The first one is the sorting. Sorting, how do we do sorting? For example, if we have 1, 2, 3, 1, and after sort, what would we have? We have 1, 1, 2, 3. So the sort will just compare this element with the element next to it. So compare the element with its neighbors. If we find that they're the same, then we will return true. If after we iterate through this array, we find no, they're all different, then we'll return false. So what is the say time complexity of this? Well, the time complexity is considered sorting. The sorting, the complexity is O(n) multiply the log n. And after that, we need to sweeping through this array, which is O(n). So we take the larger one, which is O(n) multiply log n. So the time complexity is this one. What about the space complexity? Well, when we iterate, the space depends on the sorting implementation, which usually just costs O(1). And then O(1) is our space complexity. Okay, so let's try to actually write it down here. Let's come back here. Try to write the algorithm to solve this. So the method that I just introduced is sorting. We need to sort the numbers. And then we'll go for I in range of the length of nums. And we need to compare if nums I equals to numbers the I plus 1, means that following. Because I'm doing the I plus 1 immediately, I notice I need to minus 1 here, otherwise it won't work. This will go beyond this maximum length. And if this is the case, I'm going to return true, and else I'm going to return false. So if I run this code, accepted, and if I'm going to go about this one, is accepted. So let's think about another way to solve this problem. Like I mentioned that we can also solve this problem using a, say, hash table. So how can we do that? Let's try to do. So if we build a hash table or a dictionary, we will put the element in. So let's again use the previous example, 1, 2, 3, and 1. So for the first element 1, we'll build a hash table, means that we're going to put a 1 and we're going to have this. And later we're going to add on, say, number 2 has a 1. And the third one, we're going to have a number 3 have 1. So at each step, we'll check if any element has a number larger than 1, we'll just stop checking. So in this case of 4 element, we see that by the 4th step we're going to have the 1 happen twice, and so we're going to return true. Otherwise, after we're iterating all the steps, we're going to return false. So what is time complexity? Well, we have to do the insert or the search n time, so the time complexity would be O of n. And the space complexity, since we're building a hash table or dictionary, then the space complexity is On. So compared to the sorting, we're using less time, but we need more space. So let's try to solve this. Let me just we go by trying to do a hash table equals to, we're going to build up a dictionary, and for number in numbers, and I'm going to say my hash table, I'm going to try to get this number equals to hash table dot get and number. If it's not in there, I have to return, I will get a 0, and I need to plus 1. And each time I will check if the hash saved hash table num, if it's larger than 1, then I'm going to return true and stop checking. And if after everything it doesn't return true, then I have to return false. So I'm going to submit this, and here we go. It seems pretty nice. There is another way of solving this, which is just using the set and solve it as a one-liner. Just for fun, I'm going to say it. So notice that whenever you have duplicate in one array, that the set of this array is going to have a smaller length because you have duplicates. Like you have 2 ones, the set of those array, this array is going to have 1 1. So I'm just going to compare whether the length of this nums is actually larger than the length of the set of the nums. And if that is true, it's true. If that is not true, let's test this one, then it's false. So submit is also passed. An interesting question left is that what is the time complexity of this algorithm, and what is the space complexity? See whether you can figure it out. Thank you.